Hey, there's Math 6, Unit 5, Lesson 8, Calculating Products of Decimals. We're going to multiply some decimals today. So first of all, we have a little number talk, 20 times a number, and we can see we have to evaluate things mentally. And we have 20 times 5, 20 times 0.8, times 0.04, times 5.84, some different questions like that. So as we move through these, a couple things to notice before you multiply, we can see we end up at the bottom with a 584, right? We can see that as a 5.84. So this one's going to be definitely a combination of whatever these things are, or when we add them up, it should be something like that. So first of all, we can do 20 times 5, and you might go, well, that's one you maybe know, or probably should kind of keep in your memory bank, which is going to be 100. No problem there. That's not a problem there. And again, the way of thinking about it, if mentally, if you're not sure, 20 times 5, you could think, okay, well, it's 5 times 2, which is 10, and then we add 1 0 there to make 100, right? Good deal. Here we can think about the same thing. We could think 8 times 2, which is 16, and we can put a 0 there for 160, but we notice that there's one digit behind the decimal, so we're going to have to slide that over to become 16. Okay, move a decimal point there. And here, similarly, we can do 4 times 2 is 8, and we can think about this as being 8 with a 0 for 80, and we have 2 digits behind the decimal here, so we're going to move it 1 and 2 for a 0.8. So when I think about 20 times 5.84, I'm going to find the sum of all those together, which in this case here is 116.8. All right. So do I actually know what this really is by itself? If you ask me by itself, I'd say nope. But if I deconstructed this, I would say, yep, I could do 5, I can do 0.8, I can do 0.4, and put those things together. Okay, cool. Let's move on to the next one. 2. Calculating products of decimals. A common way to find a product of decimals is to calculate a product of whole numbers, then place the decimal point in the product. So basically, do the calculation part, and then afterwards figure out where the decimal is going to go. So here's an example for 2.5 times 1.2. You can see that what they've done is they said instead of doing 2.5, we just wrote 25, and instead of 1.2, they wrote 12. So when they multiply that out, you can see what they're doing. They're doing 25. Here's 25, keeping that as a group together, times 2, which is 50. That's where that comes from right here. So this is 25 times 2. And this one here is 25, the top number, times what's the value of this? It's not 1, it's actually 10. So that's how they get the 250 there. So in case you're wondering where do those numbers come from, this is that grouping. This is like what we did before with the rectangle and saying, well, I have 25 here, and I have 12 here, and what I'll do is I'll make this into a 10 and this into a 2. Okay, so 25 times 10 is the 250, and 25 times 2 is the 50. So those are the two parts. That's where these come from. So then that's where we get here. So 25 times 12 is 300, got it there, which makes 2.5 times 1.2 equal to 3.00. And we can see that's what's happening here is we have one digit behind the decimal here and one behind the decimal there, which is a total of 2, which means they need to move it back the other way 2 in that direction. Mathematically speaking, what we're saying is that to turn the 2.5 into 25, we multiplied it by 10, and to turn this one to there, we multiplied by 10. And 10 times 10 is 100. And so then to get the 300 into that state there, we divide by 100, which is moving the decimal 2 places to the left, which is what we did here. So that's an example there. So now it wants us to use that example then, that method, to calculate the product of these ones here. Here we have 4.6 times 0.9. So the idea is, let's go ahead and we're going to do 446 times 9. We're going to remove the decimal points for now, okay, and just multiply it like a normal problem could be. So 46 times 9, depending how you want to do that here, we can think of it as 40 times 9, that's the 40 part here, right? And we can think of it being 6 times 9, and combine those together. So 40 times 9, 9 times 4 is 36, so you end up with 360, and 9 times 6 is 54. So the combination of those things together, 54 plus 360, is going to be equal to 414. Right? or multiply. 6 times 9 is 54, and then 9 times 4 is 36, plus 5 is 41. So we have 414. Now, what we did last time is we saw how many were behind the decimal to the right to move it to make it into a 25. So we went 1 this way, and then another one that way. Total of 2 decimal moves, right? So I'm going to move it back this way, 1, 2, for my final answer being 4.14. We do the same thing here. We're moving it 1 to the right and then 1 to the right, which is like, again, multiplying by 10 and multiplying it by 10 for a total of multiplying it by 100 to end up with 165 times 7. 7 times 5 is 35. 6 times 7 is 42, plus 3 is 45. And then 7 times 1 is 7, plus 4 is 11. And what do we see? We've multiplied this by 100, so now I'm going to do 1,155 divided by 100, which means I'm going to move it 2 to the left. So we're going to go 1, 2, and put it right there for an answer of 11.55. Okay? And again, if you want to think about that as a problem with a box like this, a rectangle, that's like saying 0.7 times, and then we break the 16 apart. We could do it by a 10, multiply by 6, and multiply by 0.5, right? And so 0.7 times 10, that's going to get you, in our case here, 7.0, because it's 70, move the decimal over 1. 7 times 6 is 42, 1 decimal, so we have 4.2. And then 5 times 7 is 35, and we have 2 behind the decimal, so we have 0.35. So if you were to add that up, you would have 7, 4.2, get you back in the screen here, 4.2, and then 0.35, and we add it up, what do you have? 11.55. So that's showing you kind of the rectangle way of how that works out as well. Okay, so it says use diagrams to check earlier calculations, and for each problem, which is what we just did. Okay, so let's just do it here. I got ahead of myself again. It's funny, I did it in my notes too, but that's okay. So the first one, we have 4 times 0.6. This becomes a 4, and this becomes a 0.6, and this is 0.9. So 4 times 9 is 36, and we see we have 1 digit behind the decimal, so we'll move this back 1 for 3.6. And then 9 times 6 is 54, and we have 1, 2 behind the decimal there, so we're going to slide over 1, 2 for 0.54. So 3.6 plus 0.54 equals 4. Oops, I wrote a 0 there. 4.14, which is what we had. So that's great. And the last one here, we can see we're breaking this up as a 10, a 6, and a 0.5, like we did on our other side of the paper. So 10 times 7 is 70, and 1 behind the decimal, so we move it 1 to the left there. 6 times 7 is 42, and 1 behind the decimal, so it becomes a 4.2. And then 5 times 7 is 35, and 2 behind the decimal, so it becomes 0.35. All right, number 4. About how many centimeters are in 6.25 inches if 1 inch is about 2.5 centimeters? Okay, so if in every inch you have 2.5 centimeters, so say this is an inch, right? If this is an inch, then in that 1 inch, it's the same as 2.5 centimeters. So if I end up with 1, 2, 3, 4, 5, 6, and then not all of 7, but this much, a quarter of it, 6.25 inches. So from here all the way, we can make a color for you here all the way down to there. How many of the centimeters are going to be in there? We know that's going to be a 2.5, a 2.5, a 2.5, a 2.5, a 2.5, and then we have this other little bit as well. So just kind of just quick estimation, we can see we have this combines 5, 10, 15, and a little bit more, right? So it's 15 plus as an estimate. Well, mathematically what we're doing is we're just going to take this 6.25 inches, and we're going to do this a total of 2.5 times. Okay, so we're going to have the 6.25 in groups of 2.5. So if we multiply this out, what ends up happening is you have, in our case here, we would say, let's see, how do you want to do this for y'all? We have 60, well, let's make a little box here. We can have 6.25 is like doing 6. Right, that's good there. We have a 0.2 and we have 0.05. And the 2.5 can be broken up as a 2 and a 0.5. Okay, so 6 times 2 is 12. 2 times 2 is 4. We have 1 behind the decimal, so 0.4. And 2 times 5 is 10, and we have 2 behind the decimals with 0.10. 6 times 5 is 30, and 1 behind the decimal makes us a 3.0. 2 times 5 is 10, and again 2 behind the decimal, so 1, 2, 0.1. And then 5 times 5 is 25. In this case we have 1, 2, 3 behind the decimal, so we're going to do 0.025. And if we were to add all that craziness up, we would have 12 and 0.0. We have a 0.4, a 0.10. We have a 3.0. We have another 0.1 and a 0.025. A whole lot of numbers there. So for the thousands place, we just have a 5. In the hundreds place, we have a 2. Here we have a, let's ignore this there, we have 4, 5, 6 right there, and then 3 plus 2 is 5, and 1 there is 15.625 for a solution. So that's what we have doing it the rectangle way by breaking that apart, okay, and using the area method. If I solve it this way, I can do 5 times 5 is 25, 5 times 2 is 10, plus 2 is 12, 5 times 6 is 30, plus 1 is 31. Okay, 5, and put a 0 there. 5 times 2 is 10, so we write 1, 0. 2 times 2 is 4, plus 1 is 5. And 2 times 6 is 12. And we're going to add these up. 5, 2, 6, 5, and 1. And we see we have 1, 2, 3 behind the decimal, so we're going to go 1, 2, 3. And 15.625, and we end up with the same solution there as well. Alright, let's look at activity number 3, which is an optional one for today. It says calculate each product and show your reasoning. If you get stuck, draw an area diagram to help you out there. Alright, so if you get stuck, draw an area one. We're going to go ahead and just go ahead like we've been practicing here. This becomes a 56 times 18, right? We're taking out the decimals like we did at our first one. So 6 times 8 is 48, and then 8 times 5 is going to be, well, okay, let's do this. Let's do it the long way, okay, because we've been doing that in our prior ones. This is 8 times 6, which is 48. 8 times 50, this is not 5, 8 times 50 is going to be 400, right? So that's 400. 10 times 6 is 60, and 10 times 50 is going to be 500. Okay, so it's another way of thinking about it there. So 8 plus 0 is 8, 4 plus 6 is 10, and then carry the 1, and 1 plus 4 plus 5 is another 10. And we can see that we moved the decimal over 1, 2, so we're going to go 1, 2 for 10.08. Okay. And over here we have an 8 and a 72, so we'll do 72 times 8. 8 times 2 is 16. 8 times 7 is 56, plus 1 is 57. And in this case we went 1, 2, 3, 4 behind the decimals. So we got to go back 1, 2, 3, 4 spaces there. And when I make that loop, I have to add a placeholder 0 there. So I have 0.0576 as my solution for part B. Okay, number 2. A rectangular playground is 18.2 meters by 12.75 meters. Find its area in square meters and show your reasoning. Okay, so we're going to find the area of this shape. Area is found by multiplying the length and the width together. So I can multiply those two things together to figure out what the area is going to be. Let's do this as an area method because it's an area just for fun. Okay, so I'm going to draw a big rectangle like so. And I'm going to take the 18, I'm going to break the 18 up into a 10, and an 8, and a 0.2. I know those aren't the right sizes, but that's okay. Okay, and then I'll take the 12 and break that up into a 10, and how about a 2, and then how about a 0.7, and how about a 0.05, for a total of 12.75. Okay, so that's what we did. That's just our 12.75 here and our 18.2 there. Okay, so 10 times 10 is 100, 8 times 10 is 80, and 2 times 10 is 20, and we can see we have 1 behind the decimal, so that becomes just simply 2.0. 10 times 2 is 20, 8 times 2 is 16, 2 times 2 is 4, but with 1 behind the decimal, we move it here to get 0.4. 7 times 10 is 70, with 1 behind the decimal makes 7.0. 8 times 7 is 56, with 1 behind the decimal, so we get 5.6. And 2 times 7 is 14, with 2 behind the decimal, so we get 0.14. And finally, 10 times 5 is 50, with 2 behind the decimal, so we get 0.5. 8 times 5 is 40, with 2 behind the decimal, so we get 0.40. And 2 times 5 is 10, and we have 1, 2, 3 behind the decimal, so we have a 0.010. So now adding these up, we would have 100 plus 80 plus 2 plus 20 plus 16 plus 0.4 plus a 7 plus a 5.6 plus a 0.14 plus a 0.50 plus a 0.40 plus a 0.010. Whole lot of numbers there, right? Not very lined up here. So in the thousands place, we have 0. In the hundreds place, we have 4 plus 1, which is 5. Okay, and then over here we have 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, and we have 20. Let's put a 0 there and carry a 2. Here's my decimals there. Okay, and we end up with 2 plus 2 is 4, plus 6 is 10, plus 7 is 17, plus 5 is 22. Carry the 2. 2 plus 8 is 10, 11, 12, 13 for there. Carry the 1. 1 plus 1 is 2. So we have 232.05 is our area in square meters. Again, this is a way to do it. Is it the right way? It is a right way. Are there other ways to do it? Absolutely. You can multiply it and be okay by doing just kind of some regular multiplication, right? We could convert this into 182 times 1,275. Now, I probably want to rewrite that because I don't like having a longer digit on top. So we have 182. When you multiply that out, you end up with 232050. And again, we would see we had 1, 2, 3 behind the decimal, and we have to move it over 1, 2, 3, end up in the same spot. So you could do the multiplication the way we've done before, or do an area model, different ways to approach it. And now, if 1 meter is approximately 3.28 feet, what's the approximate side lengths of the polygon in feet? Okay, so first of all, we have an 18.21, 18.2, and if a meter is 3.28, we'll multiply this by 3.28. Okay, and in doing that, what we find out is we end up with a nice fun number. Okay, we end up with 8 times 2 is 16. 8 times 8 is 64, plus 1 is 65. And then 8 times 1 is 8, plus 6 is 14. 0 there. 2 times 2 is 4. 2 times 8 is 16. 2 times 1 is 2 plus 1 is 3. 2 zeros there. 3 times 2 is 6. 3 times 8 is 24. And 3 times 1 is 3 plus 2 is 5. So we'd have 9, 10, 16, carry the 1, 7, 8, 9, and 5. And we have 1, 2, 3 by the decimal. So 59.696 is going to be the length here. So the 18.2 is 59.696 feet. And the other measurement is going to be the 12.75 times 3.28. And you multiply it out with a calculator long division, you end up with 41.82 feet for the other length there. Okay? And that is the basic idea. So I'm going to skip the Are You Ready for More for now. Let's take a look at your summary of today's lesson before we jump to the homework. It says we can use 84 times 43 and what we know about place value to find 8.4 times 4.3. 8.4 is 84 tenths and 4.3 is 43 tenths, which we could write like this: 84 tenths, 43 tenths, and you multiply that out, and so whatever you multiply here, you end up then dividing it by 100. This means that when we divide it by 100, it's the same as finding out what the 8.4 and 4.3 are actually going to be, and that helps you move your decimal. Again, if I'm dividing by 100, I'm moving the decimal 2 places to the left, and that's how I end up right there. So using product fractions such as 1/10, 1/100th, 1/1000th allows us to find the product of two decimals using the following steps. Write each decimal factor as a product of a whole number and a fraction, multiply the whole numbers, multiply the fractions, and then multiply the product of whole numbers and fractions. So there's a process there, and it does work out pretty well, and that helps us to move the decimal point around as needed to help us solve problems. Okay, take a moment here to pause, and then we'll come back and check your answers on your homework together in just a minute. Okay, here we are, homework, Math 6, Unit 5, Lesson 8, calculating products of decimals. So here are an unfinished calculation of 0.54 times 3.8 and a 0.54 by 3.8 rectangle. Which part of the rectangle has an area of 0.432? Alright, well, let's see which one that's going to be. Okay, so thinking this through here, that means it's going to be less than 1. If I have 3 of something, 3 times 0.54, or 3 times a half, it's going to be a little bit, it's going to be more than 1, okay? Here I have two decimals less than 1. If I multiply them together, what I end up with is I actually end up with 0.432 for this part here. The part that has an area of 1.62 becomes this section right there, because 0.54 is like saying half, so half of 3 is going to be like 1.5, and that looks about right there. Okay, could I show the reasoning there for how we figure that out? Sure, we could. Okay, we could do a 0.54 times 3, right? And now what we're doing here is just saying this is 54 100ths, right? Times 3, in our case here, 30 tenths. Okay, if I want to move the decimal over there. And so that becomes a really big number. That becomes 1620 divided by 1,000. So moving it 3 places to the left becomes 1.620, which is what we have there. If I want to do 0.8, I could do 54 times 8, and that becomes a 32. And this becomes 40 plus 3 is 43. And we can see we moved it over 1, 2, 3 decimals. So 1, 2, 3 decimals places there. So I'm going to put the 0.432 to show how I got that one. So what is 0.54 times 3.8? Well, we can add those up. We can do 1.620 plus 0.432. And we end up with 2.052. Again, you could multiply it if you wanted to. That's fine as well. You could also simply just do, 54 times 38, and when you multiply that out, you're going to come up with 2.052, and notice that you have 1, 2, 3 behind the decimal, so you'd move it over 1, 2, 3 right there for 2.052. All right, number 2. Explain how the product of 3 and 65 could be used to find 0.03 times 0.65. Okay, this is when you're going to want to write out in words. The idea is that if I know that what 3 times 65 is going to be, now in our case here, 65 times 3 is actually equal to 195. So if I know that the product of 3 and 65 is 195, I can use that to notice that if I multiply using decimal forms of those same numbers, that this is a form of 3 and 65. The difference is, in this case here, if I take this 3, I had to multiply by 100 in order to get that to be a whole number 3, and multiply this by 100 to get a whole number of 3, which is like multiplying the whole thing by, in our case here, 10,000. So then whenever I end up with an answer of 195, I need to divide that by the same 10,000 to put it back in decimal form, which is the equivalent of moving this back 4 decimal places, 195, and we would go 1, 2, 3, 4, decimal point there, to have a solution of 0.0195. Okay, and that's the idea. But you want to probably write that out plus some words. I'm guessing what teacher would like you to see, like you to show. Okay, use vertical calculation to find each product. So here we go. We're going to go 5, 4, 2, 4. And what we've been done so far is we put the decimals back in later on. Okay, so 4 times 4 is 16. And then 4 times 5 is 20 plus 1 is 21. Put a spaceholder 0 there because 2 or 20 times 4 is actually going to be 8. That's why it's 80. And then 2 times 4 or 20 times 5 is going to be, 100. Or 20 times 50 is 1,000. So we can say 2 times 5 is 10. Something along those lines there. And so we have 6, 9, 2, and 1. And we can see we've moved the decimal place 1 and 2. So we're going to move it back 1 and 2 for 12.96. Over here we have 167 times 35. Alright, 7 times 5 is 35. 6 times 5 is 30 plus 3 is 33. And 5 times 1 is 5 plus 3 is 8. 3 times 7 is going to be 21. So put a 0 here. We're going to do 21. 3 times 6, 6 times 3 is 18, plus the 2 is 20. So we'll write 2, 0. And 3 times 1 is 3, plus 2 is 5. We'll add that up. 5, 4, 8, and 5. We notice we have 1, 2, 3 behind the decimal. So I'm going to move this over 1, 2, 3 spots for 5.845. Alright, number 4. Number 4. A pound of blueberries costs $3.98. Blueberries $3.98 a pound, and clementines cost $2.49 a pound. What is the combined cost of 0.6 pounds of blueberries and 1.8 pounds of clementines? Round your answer to the nearest cent. So let's do our blueberries, which are $3.98 times 0.6 pounds. 8 times 6 is 48. 6 times 9 is 54, plus 4 is 58. And 6 times 3 is 18, plus 5 is 23. And we have 1, 2, 3 behind the decimal, so we're going to go 1, 2, 3. So we have 2.388, so 2.3 and 88, we're going to, it says round to the nearest cent, so 88, we're going to round that up to 89. Or to 90, 2.39 cents, so that's going to round up. And then our clementines, we have $2.49 a pound for those, and then we're going to get 1.8 pounds. So this becomes 72. 8 times 4 is 32, plus 7 is 39. 8 times 2 is 16, plus 3 is 19. And then this becomes $2.49 multiplied by 1. So I'm going to put 2, 18, carry the 1, and then 14, carry the 1 and 4, and we have 1, 2, 3 by the decimal, 1, 2, 3. So I have an 8 there. In this case here, I could either just leave it like that, or I can round it down. I'm probably just chop it off like this. So we have 4.48. If I was to leave this here, if I left this as an 8 from before and let this to 2, then it actually works out fine. This is 8 plus 2 is 10, carry the 1. And then 16, 17, carry the 1. 1 plus 3 plus 4 is 8. And we have $6.87. I don't have to worry about the 0. So that's just fine. So something pretty close to that would be a great answer. All right, number 5. Okay, so something plus 5 equals 5. We could say 0. That works just fine. 4 plus 2 is 6. 1 plus 7 is 8. And 2 plus 1 is 3. And that one's simple enough. Here, something plus 2 equals 1. Let's go with a 9. 9 plus 2 is 11, so we have to carry that 1. And 1 plus something, I have 1 and 4, which is 5, but I gotta get to 4, right? Which means I really need to get to 14. So let's do 5 plus 9 is 14. So here I have 1, 2, or 10 plus 1 is 11, so we carry the 1 there, which makes 1 plus 2 equal to 3. Okay, this next one here is subtraction. So 9 minus something gives you 8. Well, the only one I know of here that's going to work out is I can think backwards. I can think of this way and think 8 plus 9 is going to give me 17, right? So I actually need to have 17 right here, which means that's going to be a 7. The only way I get 17 is by borrowing from over here to make this one less, to borrow from over there. Okay, so 4 plus 0 is going to be 4. So if I end up with 4 here, I can't really have a 4, could I? Okay, I know I'm going to have a 4, but that means that I had to make something smaller to end up with a 4 plus 4 minus 0 is 4. So initially this had to be a 5, because I made it 1 less to borrow over here. 1 minus 0 is 1, and 6 minus 1 is 5. Okay, and that works out because 1 plus 0 is 1, and 5 plus 1 is 6. And then we're good there. Alright, number 6, which has a greater value, this minus that or that minus that? Well, let's just take a look here. So 7.4 minus 0. I have 2 zeros and 2 2's. So let's add some zeros there. Let's find out. We're going to borrow, that becomes a 10, and borrow, that becomes a 10, and borrow, and 10. So 10 minus 2 is 8, 9 minus 2 is 7, 9 minus 0 is 9, 3 minus 0 is 9, decimal, and 7. And over here we have 7.39 minus 0.2 zeros, 1, 2, and then 1, 2. So we have to borrow, that becomes an 8, a 10, borrow, 10. So 10 minus 2 is 8, 9 minus 1 is 8, 8 minus 0 is 8, 3 minus 0 is 3, so 7.388. So greater value, we have 7.39 and 38. This one is a greater value. Alright, moving down to number 7, our last one for the day. Andre's planting sapling baby trees. It takes him 30 minutes to plant 3 saplings. If each sapling takes the same amount of time to plant, how long would it take him to plant 14 saplings? If you get stuck, consider using the table. Let's go ahead and use the table. Alright, because I don't see a relationship between 3 and 14. I don't see anything multiply by real quick. I could do it, but I'd multiply by 14 over 3, which means multiplying this by the same 14 over 3. Now 14 over 3 times 30 can be done. You can certainly do that there, right? Okay, I've reduced this to 1, I've reduced that to 3 goes in here 10 times, and 14 times 10 is 140, and I'm done. So that can be done, but you may not see that right away. I could also say, how do I go from 3 to 1? That's divided by 3. So 30 divided by 3 is going to be equal to 10. Okay. And then 1 to 14 is times 14. And so 10 times 14 is 140. So whichever way you solve first works out great. Okay. That's up to you. That's it for today. Have a great day, and we will see you next time.